some level of steganography. Certainly you can do timing and volume attacks to say, well, he looks like he's logging into a bank, but banks don't usually send this much data back and forth quite like that. But at that point, we're forcing the firewall to pay a lot more attention to each TCP stream, and hopefully that's an arms race we can win.
I have a question. So if you do a trace route, for example, for a packet, how you do units? Trace route for a packet, let's say between A and B. Does it show all the Tor servers in the middle or in between, or
Tor only transports TCP streams. So the way it works is you connect to the Tor client, which is a SOX proxy, and you say, please connect me to CNN port 80. And it says, after a while, okay. And then you send, through the TCP stream you've got, get/index something or other. And it passes those bytes over to the other end and sends them to the web server. So we don't pass IP packets back and forth like TCP, like traceroute uses. We just pass the actual TCP stream back and forth. So you can't traceroute or ping.
So basically encapsulate the TCP packet to some other packet and then...
No, it's not the packets. We actually look at the contents. We look at what you say over the TCP connection. And then we pass that to the other end of the Tor network.
And that's why you're saying the VM solution is much better, because you can encapsulate every packet from any application that comes out of the VM and then send over the Tor network.
That is a new design that the VM thing is a piece of, but isn't going to totally do. Because along with running a VM where we intercept everything, we would also need to switch the design of Tor over so that it can handle UDP and IP, and so that we're encapsulating packets and moving the actual IP packets to the other side and sending them. And that's harder than it sounds, and it sounds hard.
I actually think it's much easier because I kind of do similar works. You can, if you do, instead of sending a TCP packet or TCP stream, you send the Ethernet frame over the network. Then you don't have to deal with what's the semantics of this application or what's the semantic of this packet.
We're getting closer to being able to do that. Some of the challenges are your TCP behavior is going to identify what sort of OpenBSD and so on you're using. And if we just move the IP packets from one end to the other, then the web server can say, I know what sort of user I'm talking to. I can learn some about what they're doing. That's one issue. Another issue is exit policies right now just specify addresses and ports. And if we have to specify TCP addresses and TCP ports and UDP addresses and UDP ports and ICMP types this, and this, and BGP no, and stuff like that, it gets more complex. And the exit policy needs to tell the client before she picks her exit node whether it's going to support the whole conversation. And if the conversation is a big pile of different types of IP packets, it's hard to predict how to pick an exit node that will handle that. We can certainly chat more about that afterwards, because I'd love to do it, I just don't know how. There's a fellow at Waterloo in Canada who is working on this, and there's another fellow right here who's working on this. So I'm hoping that in time we'll be able to move to that. Last question, comment? Okay, thank you.